Hi everyone, my name is Kat. Today I'll be presenting on salmonellosis, a disease caused mainly by Salmonella enterica. I'll cover the organism, how it spreads, symptoms, real outbreaks, and ways to prevent it. Salmonellosis is one of the most common foodborne infections worldwide. People usually get it by eating contaminated food or drinking contaminated water. Most infections cause diarrhea and fever, but some strains like typhi cause a much more serious disease called typhoid fever, which is what we'll be focusing on today. Even with good sanitation, salmonella continues to be a major public health issue. Onto the infectious agent. Salmonella is a gram-negative rod-shaped bacterium with flagella, which help it move. As you can see in the image that I provided on the up right corner, it shows the flagella and how it actually looks, which I really like that I was able to find some of these images to provide in the slides. It's a facultative anaerobe, meaning it can live with or without oxygen. It belongs to the Enterobacteriaceae family, the same group as E. coli, and it grows best in human body temperature, making it highly effective in infecting people. The appearance of the organism. Under the microscope, Salmonella appears as pink gram-negative rods as seen in the bottom left corner. On selective media that detect hydrogen sulfide, it forms pale colonies with black centers. That black color is one of the main features labs use to identify in stool cultures. Notable stains. Even though S. enterica has more than 2,500 serotypes, only a few cause human disease. Typhi causes typhoid fever, which is a systematic infection. Typhimurium, and enteriditis cause the majority of food poisoning cases today. Some strains only infect humans, while others infect poultry, cattle, and reptiles, which is why we see so many food-related outbreaks today. Taxonomy. Here's where Salmonella fits in classification. It is the Protobacteria phylum and Enterobacteriaceae family. It is closely related to E. coli and shares similar traits, including being gram-negative and capable of living in environments with variable oxygen levels. Onto my favorite part, the history. Salmonella was discovered in the late 1800s, and even though Theobald Smith isolated it, it was named after Dr. Salmon. One of the most important historical cases is Typhoid Mary, which I would love to get more into in class. And it is the first known asymptomatic carrier in the US. She worked as a cook and unknowingly infected multiple families because she never showed symptoms. She didn't believe she was sick and kept working, which led her long-term quarantine. Her case changed public health laws and taught us how dangerous carriers can actually be. Recent outbreaks today. Salmonella outbreaks still happen frequently. In early 2025, cage-free eggs caused 95 infections across 14 states. A frozen food outbreak later that year caused more hospitalizations as well. One of the biggest was linked to backyard poultry, with over 400 cases in 47 states, with examples like these show how easily Salmonella spreads through food and animals. Research efforts that are happening right now. Current research focuses on how Salmonella invades host cells, how it survives in low oxygen environments, and how it becomes antibiotic resistant. Scientists are also improving detection methods in food systems to identify contamination earlier. Future outlook. Because Salmonella is found in so many animal reservoirs, completely eliminating it is impossible. Antibiotic resistance is increasing, especially in typhi. Future control depends on better sanitation, strong outbreak surveillance, vaccines, and genomic monitoring to trace contamination sources a lot quicker than we are right now. Major metabolic pathways. One important pathway in Salmonella is the TCA cycle, as spoken this semester, which helps produce energy and metabolic intermediates. What makes Salmonella successful is its ability to switch from using oxygen to using alternative electron acceptors like nitrate or tetrathionate. This lets it survive inside the gut where oxygen levels are low. This is why it's so important to speak about it, because It's able to survive even if it's packaged, even if it's sealed. So you go to the store, you pick up that sealed chicken, you pick up the cage of eggs, and it's still going to survive for that month that it might be sitting on the shelf waiting for somebody to purchase it. Diagnosis starts with symptoms, but confirmation requires lab testing. Stool culture is the gold standard, and we often see those black centered colonies for typhoid fever. Blood cultures are more useful in early infection because typhi spreads through the bloodstream before appearing in the stool. So it's going to spread through the bloodstream first because it has to replicate itself, and you don't see it until the stool much later because of the amount of replication that happens within your body. It starts to get flushed out in your stool. For treatment, most salmonella infections don't need antibiotics. Hydration is the most important treatment. Antibiotics are reserved for severe cases or typhoid fever. Drugs like azithromycin and ceftriaxone are commonly used, but resistant patterns vary depending on the region. Antibiotics are something that I think bacteria are constantly evolving, especially Salmonella. It's been discovered since the 1800s, so to think that it's not gonna figure out how to battle against the antibiotics that we are constantly consuming is it's impossible not to assume, right? So it's hard to go to the hospital and for them to give you the antibiotics that you may want or you may feel like you need in order to beat it. But in reality, if you just stick to the fluids, you stick to the right nutrition, and you just go by the old way route, then you might just survive salmonella within 4 to 7 days, which is the period that the symptoms last within your body. You're going to become asymptomatic at some point, is why you have to remain sticking to those safety procedures, washing your hands, maintaining sanitation in your kitchen when dealing with foods that may be contaminated with salmonella. Prevention. We're going to go ahead and move to pathogenesis, actually. So, pathogenesis, salmonella uses a type 3 secretion systems, which act like syringes to inject proteins into host cells. This forces the host cell to take the bacteria in. Once inside, salmonella lives in the projected compartment and can multiply. Typhi also has the VI capsule, which helps it hide from immune detection. I think this was one of my favorite parts when doing my research for salmonella. The VI capsule creates like a shield that when it enters the small intestine, your body isn't gonna be able to detect it, so it's easily gonna be able to inject itself into that macrophage and then replicate itself. And then by the time it's already multiplied, it's too late because your immune response system is like, oh, which is causes that reaction of inflammation, diarrhea. Like your body's freaking out because it's like, when did you get here and why did you multiply so fast? The pathology. In the intestine, salmonella damages epithelial cells and triggers inflammation that leads to diarrhea, cramps, and fever. In typhoid fever, the bacteria spread to organs like the liver, spleen, and gallbladder, causing high fever and sometimes intestinal bleeding if untreated. For transmission, salmonella spreads through the fecal-oral route. Major sources include undercooked eggs, poultry, beef, contaminated water, and contact with reptiles or backyard poultry. Human carriers like typhoid Mary can also spread typhi without ever feeling sick. Incidence and prevalence. In the US, about 1.35 million salmonella infections occur each year. Globally, non-typhoidal salmonella causes around 94 million cases. Typhoid fever affects up to 20 million people annually, especially in areas without safe water and good sanitation. At-risk populations, children, older adults, and immunocompromised individuals are at higher risk. People who handle animals, like farmers or reptile owners, also have higher exposure. Communities without clean water are especially vulnerable to typhoid fever. Signs and symptoms. Common symptoms include diarrhea, abdominal cramp, fever, nausea, and vomiting. Typhoid fever causes prolonged high fever, fatigue, and sometimes rose-colored spots on the chest, which are very rare. They're not seen in many cases, and when they are, it's something that you should call yourself lucky to have because you're easier to detect that you do have salmonella. And severe cases can lead to intestinal complications. So the immune response to this, as I talked about in the previous two slides. The innate immune system responds first with macrophages and neutrophils, which is the tricky part that I think Salmonella has been able to understand. Is that that's the first response that your body is going to react to, but it's literally giving it its new home, and it just becomes the worst mistake that your body can make, which it's not its fault, but Salmonella is smart on its end with that one. Salmonella can survive inside macrophages, which helps it spread. The adaptive immune system produces antibodies and activates T cells, which are necessary to fully clear the infection. Um, yeah, that's basically it. So to close, Salmonella remains a major global health concern because of its ability to survive in food, animals, and the environment. Prevention relies on sanitation, safe food handling, vaccines, and early detection. That's basically it. Thank you for listening. I'm so excited to go to class and be able to talk about the VI capsule, the macrophages, and how it engulfs it. Typhoid Mary, which is a really good story with many, many side connections and drama involved in it. Um, yeah, thank you for watching.